Welcome back to our channel. Today we will discuss about the theorem derivative of f of x is equal to x raised to n is nx raised to n minus 1 for any positive integer n. D by dx of x raised to n equals nx raised to n minus 1. Proof. We have the definition of the derivatives. It is also known as the first principle of derivative. That is f dash x equals limit h tends to 0 f of x plus h minus f of x by h. Here given that f of x equals x raised to n. To this function f of x is equal to x raised to n, we apply first principle of derivative. What is our f of x? F of x equals x raised to n. Next find f of x plus h. We can find f of x plus h by replacing x with x plus h. That is f of x plus h equals x plus h whole raised to n. What is f of x? F of x equals x raised to n. Then f of x plus h. How to find f of x plus h? By replacing x with x plus h. So f of x plus h is equal to x plus h whole raised to n. Now substitute the values of f of x plus h and f of x in the formula f dash x equals limit h tends to 0 f of x plus h minus f of x by h. Here f of x equals x raised to n and f of x plus h is equal to x plus h whole raised to n. So f dash x becomes limit h tends to 0 x plus h whole raised to n minus x raised to n by h. Now we need to expand x plus h whole raised to n. How to expand x plus h whole raised to n? For the expansion of x plus h whole raised to n, we need binomial theorem. We already know about the binomial theorem. What is binomial theorem? A plus b whole raised to n equals nc0 a raised to n plus nc1 into a raised to n minus 1 into b plus nc2 into a raised to n minus 2 into b square plus etc. plus n minus 1 into a into b raised to n minus 1 plus ncn into b raised to n. This is our binomial theorem. This theorem is applied to expand x plus h whole raised to n. So x plus h whole raised to n equals nc0 into a raised to n. Here we write nc0 into x raised to n. Here the first term is x and the second term is h. Here first is a and second is b. So nc0 into x raised to n plus nc1 into x raised to n minus 1 into h plus nc2 into x raised to n minus 2 into h square plus ncn minus 1 into x into h raised to n minus 1 plus ncn into h raised to n. So nc0 is 1, ncn is 1, nc0 is also 1. So substitute the values of nc0, nc1, nc2, etc. up to nc. Then this equation become x raised to n plus n into x raised to n minus 1 into h plus nc2 into x raised to n minus 2 into h square plus etc. n into x into h raised to n minus 1 plus 1 into h raised to. So how to find the values of NC0, NC1 and NCN? We know that NCR equals n factorial by r factorial into n minus r factorial. And we know that 0 factorial is 1. Then what is NC0? N factorial by 0 factorial into n minus 0 factorial. N factorial by 0 factorial is 1. N minus 0 becomes n factorial. N factorial get cancelled. So the answer is 1. What is NC1? By applying this formula, NC1 equals n factorial by 1 factorial into n minus 1 factorial. N factorial is 1 into 2 into 3 into etc. up to n. The previous term, of course, n minus 1. So 1 into 2 into 3 into etc. n minus 1 into n by n minus 1 factorial. We know that 1 into 2 into 3 into etc. into n minus 1 is n minus 1 factorial. 1 into 2 into 3 into etc. up to n is n factorial. Then 1 into 2 into etc. up to n minus 1 is n minus 1 factorial. So instead of this, we write n minus 1 factorial into n by n minus 1 factorial. These two n minus 1 factorial get cancelled. The answer is n. Then n minus 1 is n factorial by n minus 1 factorial into n minus n minus 1. N minus n plus 1. These two n get cancelled. Then becomes n minus factorial 1 factorial into 1 factorial. NC1 equals, we got n minus 1 factorial by n minus 1 factorial into n by n minus 1 factorial. Similarly, this n factorial can be written as 1 into 2 into 3 into etc. n minus 1 into n divided by n minus 1 factorial into 1 factorial. This 1 into 2 into 3 into etc. n minus 1 can be written as n minus 1 factorial. These two get cancelled. Then we got n. That is NCn n factorial divided by n factorial into n minus n factorial. These two n minus factorial n factorial get cancelled. N minus n factorial becomes 0 factorial. We know that 0 factorial is 1. So the answer is 1. So the value of NC0 is 1. NC1 is n. NCn minus 1 is n. And NCn is 1. Substitute the values of NC0, NC1, etc. NCn in the equation x plus h whole raised to n equals NC0 into x raised to n plus NC1 into x raised to n minus 1 into h plus etc. plus NC0 into h raised to n. Substitute the values of NC0, NC1, etc. up to NCn. So 1 into x raised to n plus n into x raised to n minus 1 into h plus etc. plus 1 into h raised to n. So x raised to n plus n into x raised to n minus 1 into h plus etc. plus h raised to n. These all terms containing h. So we take h is taken as a common, x raised to n plus h into n into x raised to n minus 1. This is h taken outside plus etc. plus n into x into h raised to n minus 1. 1 h we take here. So h raised to n minus 1 become h raised to n minus 2 plus h raised to n minus 1. Put the value of x plus h whole raised to n in the equation f dash x equals limit h tends to 0 f of x plus h minus f of x by h. So what is the value of x plus h whole raised to n? That becomes x raised to n plus h into n x raised to n minus 1 plus etc. plus h raised to n minus 1 minus x raised to n by h. This minus x raised to n plus x raised to n get cancelled. Then the remaining term right here, h into n x raised to n minus 1 plus etc. plus h raised to n minus 1 by h. These two h get cancelled. Then limit h tends to 0, n x raised to n minus 1 plus etc. plus h raised to n minus 1. So here h approaching to 0. All the other terms containing h other than n x raised to n minus 1. So all terms containing h tends h that tends to 0. Here we have the remaining only n x raised to n minus 1. So f dash x equals n x raised to n minus 1. That is d by dx of x raised to n equals f dash x equals n x raised to n minus 1. D by dx of x raised to n is same as f dash x, which is used to solve all the variable having power. How to apply this formula? Example 1, d by dx of x raised to 4 equals, here n equals 4. What is d by dx of x raised to n? N x raised to n minus 1. Here d by dx of x raised to 4 equals 4x raised to 4 minus 1. That is equal to 4x raised to 4 minus 1 is 3, 4x cube. Similarly, d by dx of 1 by x raised to 5, that can be written as x raised to minus 5. That is equal to minus 5 into x raised to minus 5 minus 1. That is equal to minus 5 into x raised to minus 6. Minus 5 minus 1 equals minus 6. D by dx of root x. Root x is same as raised to 1 by 2. X raised to 1 by 2 is root x. That is equal to n. Here 1 by 2 is n. 1 by 2 into x raised to 1 by 2 minus 1. That is equal to 1 by 2 into x raised to minus 1 by 2. What is d by dx of x? D by dx of x is same as d by dx of x raised to 1. Then what is d by dx of x raised to 1? Here n is 1. So apply this formula, d by dx of x raised to n equals nx raised to n minus 1. Here n is 1. 1 into x raised to n minus 1. 1 minus 1, that is equal to 0. We know that x raised to 0 raised is 1. So instead of this we write 1. 1 into 1 becomes 1. Thank you. Welcome back to our channel. Today we will discuss about derivative of polynomial and trigonometric functions. Derivative of polynomial function. A function which is of the form f of x equals an x raised to n plus an minus 1 x raised to n minus 1 plus etc. plus a1x plus a0. Be a polynomial function, then d by dx of f of x equals n into an into x raised to n minus 1 plus n minus 1 into an minus 1 into x raised to n minus 2 plus etc. plus a1 equal plus 0. Here we use the formula d by dx of x raised to n equals n x raised to n minus 1. Here an minus 1 etc. up to a0 are the constant value. If we have a constant associated with a variable, we have a constant associated with a variable, we have to remain the constant as it is, then find out the derivative of the variable. If all the variables having the power, so find the derivative using the formula d by dx of x raised to n equals nx raised to n minus 1. First we here find d by dx of an x raised to n. We know that an is a constant. So remain the constant as it is, then find the derivative of x raised to n. Then how to find the derivative of x raised to n? We know the equation derivative of x raised to n equals n x raised to n minus 1. So apply that formula here, n x raised to n minus 1. Oh, here we write just n into an into x raised to n minus 1. Similarly, find the derivative of all the other functions. Is it clear? Example, 6x raised to 100 minus x raised to 55 plus x. Solution. D by dx of 6x raised to 100 minus x raised to 55 plus x. So d by dx of 6x raised to 100 minus d by dx of x raised to 55 plus d by dx of x. We know the equation d by dx of x raised to n equals n x raised to n minus 1. Here we know that 6 is a constant, so we write here or keep the constant as it is, then find the derivative of the variable d by dx of x raised to 100 minus d by dx of x raised to 55 plus d by dx of x. D by dx of x is same as d by dx of x raised to 1. So 6 into, what is the equation for finding the derivative? Nx raised to n minus 1. So here n is 100. So 100 into x raised to 100 minus 1. Similarly, 55 into x raised to 55 minus 1 plus 1 into x raised to 1 minus 1. So 6 into 100 into x raised to 99 plus 55 into x raised to 54 plus x raised to 0. 6 into 100 is 600. 600 x raised to 99 minus 55 x raised to 54 plus 1. We know that x raised to 0 is 1. By this way, we can find the derivative of any polynomial function using the formula d by dx of x raised to n equals nx raised to n minus 1. Derivative of trigonometric function. Here we have taken the main trigonometric functions such as sin x, cos x, tan x, cosec x, sec x and cot x. First one, derivative of sin x equals cos x. Derivative of cos x equals minus sin x. Derivative of tan x equals sec square x. Derivative of cosec x equals minus cosec x cot x. Derivative of sec x equals sec x tan x. Derivative of cot x equals minus cosec square x. These are the derivatives of trigonometric functions. Is it clear? Along with that, derivative of some other functions are d by dx of log x equals 1 by x, d by dx of a constant is 0, d by dx of x raised to n equals nx raised to n minus 1. This is about the derivative of polynomial and trigonometric functions. Thank you.